Hello class, I hope you're having a wonderful day. Today I would like to take a look at one of our practice problems that requires us to use the substitution method. So what let's do is let's read the problem, and we're going to sketch a quick diagram, and then we're going to walk through the process to solve this problem. So let's go ahead and get started. So a bicycle rider pedals with constant acceleration to reach a velocity of 8.55 meters per second in 3.75 seconds. During the period of acceleration, the bike's displacement is 20 meters. Calculate the initial velocity of the bike. So let's first draw a quick diagram. So we have our initial position, and then we have our final position, and our change in displacement here. I'll go ahead and place a dimension. Delta D is equal to 20 meters. I'm going to label our initial velocity. Now we don't know what it is, so I'm going to put a question mark, but we do know that the units need to be in meters per second. Okay, so our final velocity is 8.55 meters per second, and the time required to travel the 20 meters is 3.75 seconds. So delta T is equal to 3.75 seconds. Okay, so we do not know the acceleration of the object. So I'm going to say acceleration, we don't know what it is, but we do know that the units need to be in meters per second squared, and then we do not know the initial velocity of the object, okay? But we do know that the units should be in meters per second. So what let's do is let's start out with the base equation for acceleration. We know that acceleration is equal to the change in velocity divided by the change in time. So I have final velocity minus initial velocity divided by delta T, okay? Now, the problem is asking for us to calculate the initial velocity of the object. So what let's do is let's isolate initial velocity. So I'm going to first multiply by delta T on both sides of the equal sign. On the right-hand side of the equal sign, delta T cancels, okay? And then, so here, let me rewrite this here. Delta T times acceleration is equal to final velocity minus initial velocity. So what let's do now is let's subtract this from both sides of the equal sign. You see here that we have an understood plus sign. This is a positive value. So I'm going to subtract it from both sides of the equal sign, and this will give me negative final velocity plus delta T times our acceleration is equal to negative initial velocity. What I want to do is get rid of this negative sign, so I'm going to divide both sides by -1, and this is going to give me initial velocity is equal to my final velocity minus my time interval multiplied by my acceleration. So I'm going to put a dotted box around this guy here because we are going to need this equation, okay? So the next thing I want to do is look at another one of our equations that we learned in chapter 3. Is the final displacement is equal to initial displacement plus the product of the object's initial velocity and time interval plus 1/2 times the acceleration multiplied by the time interval squared, okay? Now, what I want to do is immediately identify that the initial displacement of our object is 0, okay? So we're starting from a position of 0, and we're changing our position a positive 20 meters. So immediately, this guy here goes to 0. We don't even need to mess with it anymore, okay? Now, if you notice in this equation, we have an initial velocity. Well, you've already solved for initial velocity right here. It's equal to final velocity minus the time interval times our average acceleration, okay? So what I want to do is I want to plug in this right here. We're using the substitution method. So what I've got is the final displacement of my object is equal to, we have initial velocity, but we're going to use final velocity minus delta t times acceleration. So what I'm going to do, just to be clear, is use some hard brackets to show that I am using the substitution method. So I have final velocity minus my time interval times acceleration. Okay, that's what initial velocity equals. Come on in. And then we're going to multiply this by the time interval, delta t, plus 1/2 multiplied by our acceleration, then multiplied by our time interval squared. Okay? Now, at this point, what we want to do is distribute our time interval in for our substituted equation here. So when I do that, I have our final displacement is equal to our final velocity times our time interval minus, now we're multiplying delta t in here, so what we're going to have is delta t times a. So that's going to be delta t squared times our acceleration plus 1/2 times acceleration times delta t squared. Okay? At this point, we need to plug in our known values, and then we're going to solve for acceleration. So our final displacement, we have 20 meters. This is equal to our final velocity, 8.55 meters per second, times our time interval of 3.75 seconds, minus 3.75 seconds. We're going to square that, times acceleration, plus 1/2 times acceleration times 3.75 seconds squared. Okay, let's grab our calculator. So the product of these two values, 8.55 meters per second times 3.75 seconds, is going to give me 32.0625. Now let's take a look at the units. I have meters per second times seconds, and algebraically we can write this as seconds over 1. So the seconds cancel, leaving us with units of meters. Okay? So minus 3.75 seconds squared gives me 14.0625. And not only are we required to square the numerical value, we have to square the unit value too. So seconds times seconds is going to be seconds squared times our acceleration plus 1/2 times acceleration times 3.75 seconds squared. Now, this value here, 3.75 seconds squared, you've already calculated that, and we're going to divide it by 2 and then multiply by acceleration. So 14.0625 divided by 2 is going to be 7.03125 seconds squared times our acceleration. Now at this point, we need to combine like terms. So we need to combine these two values because they both have units of meters. And right here, we can combine these. They have the same units and the same variable, acceleration. So what I want to do here, there's an understood plus sign here. This is a positive 32.0625 meters. What let's do is subtract this from both sides of the equal sign. So 20 meters minus 32.0625 meters will give us a negative 12 0.0625 meters. This is going to be equal to, so let's go ahead and combine these two values here. This is going to be a negative 7.03125 seconds squared times our acceleration, okay? Now remember, in this step, we're trying to calculate the acceleration of the bicycle. So this is what we're looking for. So we want to isolate this on one side of the equal sign. So what we're going to do is divide both sides by a negative 7.03125 seconds squared. When we do that, the negative 7.03125 seconds squared cancels. Okay, so what I have here is 12.0625 divided by 7.03125, and I get 1.715. So our acceleration is equal to 1.715. And let's take a look at our units. We don't have anything that cancels here. We have units of meters per second squared. Meters per second squared. Okay? So we have a positive acceleration. And whenever we have a positive acceleration, that means that our final velocity is greater than our initial velocity. So looking at my diagram that I drew up here, our final velocity is greater than our initial velocity. So just to make a prediction and do a reality check, we know that our initial velocity, this value will be less than 8.55 meters per second. Okay? So what we're going to do now is we are going to plug our value, our calculated value for acceleration, back into this equation, okay? And so what we have here is initial velocity is equal to the final velocity of the bicycle, which the problem gave that to us, 8.55 meters per second, minus our time interval times our acceleration. So minus our time interval of 3.75 seconds. And our acceleration is a positive 1.715 meters per second squared. Okay? So what we're going to do is we're going to take the product of these two values here. So initial velocity is equal to 8.55 meters per second minus 3.75 seconds times 1.715 meters per second squared. This gives me 6.43. Now let's take a look at the units. So I have seconds, which we can write as seconds over 1 times meters per second squared. So we can see that one of our seconds cancels out. So it leaves me with units of meters per second. Okay? Now, we can subtract the 6.43 meters per second. Alex, are you leaving?
Yeah.
All right. Have a wonderful weekend, sir. I'll see you on Monday.
You too. See you.
All right. Thanks. Okay. So what we're doing here is subtracting 6.43 meters per second. And we're allowed to do that because these values have the same units. Okay? So let's do 8.55 minus 6.43. And this gives me 2.12. So our initial velocity is 2.12 meters per second. All right, and that is our answer. So I'm just going to label this on our diagram. So initial velocity, we have 2.12 meters per second. Okay, well, I hope that solving this together has helped you out using the substitution method. As always, if you have any questions, please call me or send me an email or contact me through Canvas, and I will get back with you as soon as possible. I hope you have a wonderful day.